Okay, it's Catvolution with Cyril Negre again, and he's going to describe the Airpod.
Okay, the Airpod is a new product we unveiled last week in Carros in south of France. It's a very light product, 220 kilos, that enables to take 3 people inside for urban transport. The idea is to have 3 people in something like 2 meters long. It is 2.07 meters, very short. It has 2 wheels in the back and 2 wheels in the front, but the wheels in front are not driven. And the idea is to drive this system with a joystick, and it's very agile, and you can go in the traffic very easily. It is a brand new product that we want to put on production somewhere in the middle of next year. We think that in March we can start producing them. We will have something like 40 to 50 cars. Well, no, sorry, it's not a car. It's called transporter. It is different for us than a car because it's very special. So we will have, we hope, something like 50 pods for test and for giving them to our partner that have signed some contract, because this is going to be produced in the same plant as the one cat, sorry, the one flower now, because we have also to change that name. It becomes flower. So this is the Airpod, and then there is the one flower, city flower, mini flower, multi flower. So it's going to be produced in the same plant as the one flower, and because it is on a license base less than 500 kilos.
Okay. What's the continuous speed and range of the Airpod?
The Airpod will have a maximum speed of 45 km per hour, and the range in the urban cycle using this transporter is around 220 km. It is very light. There is not a lot of friction due to the wheels because they are very small. We manage a system with quite good performance concerning the range, with a tank of 175 liters at 350 bars. But as it can be refilled on an air station within 1.5 minutes, very rapidly, range can be even shorter. It won't be a problem for urban use, because in town, you know, people are driving their car around between 18 km per hour for the average value, and 20, 22 depending on the countries. So basically you can refill the Airpod very rapidly, so range won't be a problem.
Okay. So how does the joystick work?
The joystick works in a very easy way. It's something that you feel, because when you want to drive the pod, you just have to accelerate, turn more or less. And in a car, you are doing exactly the same thing without thinking of that. You are accelerating all the time and decelerating on the accelerator. You are never pushing all the time the same pressure on the accelerator, and you are always controlling your car like that. You don't feel it and you don't realize it, but you are doing like that. And it's going to be the same on the pod. You're going to accelerate less or more and turn less or more. It's just something that you can feel.
Okay. What's the sound like on this? Does it make a lot of noise?
The noise is different. We've done some tests by taking out a diesel engine from a car, an existing car, and putting an air engine inside, where we could put a lot of air inside and do the test. And we've seen that just by putting the engine inside this car, same car, we had 20 dB less than this engine. The thing is that the noise is different. It's not something that people knows. Frequency are different. The feeling of the noise is different, and I know that we can work a lot, not a lot, but we can work and try to manage this noise, but it's not loud. It is different.
So how will this look running on city streets or communities?
With the pod?
Yes, with the pod.
I think it's going to be very agile. You can go in the street and turn. You can park the pod perpendicular to the road. You can do a lot of small streets. You can run into small streets, and I think it's a good point for the cities. Well, of course, the feeling running without emission is a good feeling.
Yeah. What was the most challenging engineering aspect of building these pods?
Well, you know, when you are developing, it's something that you are doing step by step. So each time you have a problem, you find some solution that sometimes are advantages for other device in the system you are developing. For example, at the beginning we started with 2 engines, one per each wheels, and we've run the basement of the pod using these two engines, but we've seen that we had some problem of controlling the speed of both, so we've decided to go on one engine and control the axis of the wheels, and it's an advantage because the lighter, cheaper, and easy to manage. So the idea is that when you are developing an idea like that, you don't start with the global vision of it. You start with specification that you want to achieve, but then step by step it can change. It can be a little bit different from what you think before, because you can't one morning wake up and say, okay, I want to have a pod with 2 wheels, 2 engines, 2 wheels in the front, 3 people sits like that, and it is something that comes step by step. But the whole project, you are looking today to the prototypes of the pod. The work we've done on the pod started in December for the first idea, to put 3 people in the pod with the driver in the front and the people in the back turn on the opposite way. And this idea was in last December, and we started physically to work on the project and to put engineers in defining things and designing things just in the beginning of March. And from March to today we have 2 running pod, prototype of course, on which we are still working on, because we want to produce this pod in around March or April next year. But you can see that it's very short delay to build a pod. But for the technology of the engine, it is still the flower technology.
Flower power?
Flower power.
So is this the final product, or what more things do you have to work on?
This is the first prototype. We still have to work on a few things, suspensions, drivability, and these kind of things, for having people able to drive it. I think within 1 month, 1 month and a half, we can have people coming here and test the board and see how it is with the joystick, etc. For the moment we are doing engineers and people from MDI, step by step are driving the pod, but within 1 month, 1 month and a half, we will have something drivable very good for people. And this is part of the work we have to do in parallel of putting the production tooling system in process to arrive in April with something that we can produce.
So how many do you expect to produce in a day?
It's going to be built in the same plant as the one flower, and I think, I'm not sure at all, we should ask my father, but I think it is 3 pods per hour.
3 pods per hour?
Yes.
That's pretty good.
Yeah, well, it's quite simple.
And how much are they going to be sold for? Do you know roughly?
Yes, the target is around 6,000 euro.
6,000 euro?
Yes.
Now for golf carts, this could be used as a golf cart, could it?
Yes, I think, but for golf cart it will be a lot more simple. You can change the body and do something a lot more simple. Okay. Because you've seen how it's done. You have the frame with the air tank and the engine and everything, the technical basis, and then we just put a body on it. Okay. So using the basic technical platform, we can then change the shape of what we are putting over to do some golf cart and other market.
Okay, so it's going to be one chassis with
a body on
different platforms.
We can change the body.
Okay, and the other bodies are the cargo pod?
Post office, fleet. You can have a railway station, airports, company that can be interesting in having some pods. A lot of there is a huge market.
Now, because it doesn't produce pollution, and it can be used indoors inside factories.
Yes, big factories to transport people from one point to the other one without problem.
So will this be aimed towards replacing electric vehicle fleets inside buildings?
It's a possibility, yes. Yeah. With the possibility to fill the tank within 1.5 minutes. No, 1 minute and a half.
Yes, that's 1.5 minutes. Yeah, that's right. Okay, great. Thank you very much.
You're welcome.
Hey.